Okay, Assalamualaikum. Actually, we have finished our syllabus until logistic regression. Kan? Previous lecture. Okay, so for today's lecture, I want to give you an example. Okay, explain the example from past year paper on how to interpret the coefficient and also how to read the output from SPSS. Okay, let's begin the first example. Okay, medical scientists from a cancer research center are interested to predict the occurrence of tumor in the human brain. Okay, 0 and 1. 0 for no occurrence of tumor. 1 is occurrence of the tumor. Okay, so the occurrence of the tumor ni will be our y, which is the dependent variable 0 and 1. Okay, based on the specific antigen values, okay, SAV. Okay, so SAV is one of the continuous variable. Okay, it is an independent variable with a continuous measurement. Okay, age group 1 for less than 50 years old and 0 for more than 50 years old. Okay, so age group adalah qualitative variable, and Gleason score from 1 to 10 indicating cancer's level of aggressiveness. So means that GS ni, Gleason score adalah independent variable that have the level of measurement yang adalah continuous, okay, ratio. Okay, using a binary logistic regression, the following estimated model was obtained. Okay, so for this example, for this case study, Y adalah occurrence of the tumor brain. Kita nak predict the occurrence of the tumor brain, whether it occur the tumor or not occur the tumor. So 0 and 1. Okay, because of that, kita boleh proceed dengan binary logistic regression. And if you look at the independent variables, okay, the independent variables are mix of the qualitative dan juga quantitative variables. We have SAV dan GS adalah continuous scale, okay, dan age group adalah qualitative variable nominal 0 and 1. Okay, but actually untuk qualitative variable, for independent variable, the qualitative the nominal data, the nominal variable can be more than 2. Tapi untuk Y, it only 2 level saja. Yes or no. Okay, male or female. Tapi untuk independent variable, it can be 0, 1, 2, 3. Maksudnya dia punya level can be more than 2. Okay, we go back to our example here. So the binary logistic regression will write as ln P over 1 minus P. Okay, you know this term adalah binary logistic regression equal to, we have the negative 6.390 for constant, plus 0.027 coefficient for SAV, negative 1.0211H adalah coefficient for H, plus 1.079 adalah coefficient untuk Gleason score. Okay, we have this equation. Okay, so next we can interpret the coefficient, each of the coefficient for the logistic regression. But untuk logistic regression is special sikit. Kalau nak kita tak boleh nak interpret the coefficient directly, we need to change kepada odd ratio. So how to find the odd ratio? It is the exponent power of the coefficient. So kalau kat sini E untuk SAV, E power of 0.027, it is 1.027. So 1.027 yang kita akan interpret. Okay, so because of SAV adalah continuous variable, so we can interpret it as for 1 mg ml, kan, itu adalah milligram per milliliter adalah unit untuk SAV. Okay, for 1 milligram per milliliter, increase in the SAV, specific antigen value, will increase, okay, increase but dia positif kan, so increase dan increase, will increase the odd of getting tumor occurrence adalah Y. Kenapa kita tulis sebagai getting tumor? Sebabnya 1 adalah yes. Kalau 1 adalah no, so the odd of not getting tumor. Okay, because of here 1 adalah yes, so will increase the odd, kena ada perkataan odd ni, the odd of getting tumor occurrence by a factor of 1.027 times. Okay, so ini adalah interpretation if the independent variable adalah continuous variable. Okay, next, let's say we want to interpret the odd ratio for age. Age tadi adalah age group, which is the qualitative variable. Okay, so E power of the coefficient for age tadi adalah negative 1.021. So it will be 0.3602. Okay, so we can change ke dalam bentuk 1 over 0.3602 sebab kita nak interpret dalam bentuk yang more meaningful. Kalau kita interpret 0.3602 pun boleh, tak ada masalah sebenarnya. Okay, so kita boleh katakan a person who age 50 years and above. Kenapa? Sebab 1 adalah less than 50 years old, tapi sebabkan kita tukar kepada tadi sebenarnya 0.3602 ni, kita boleh interpret based on 1 tadi. 1 ni adalah less than 50 years old, tapi kita tukar ke dalam bentuk kita tukar 1 over 0.3602, it will be 2.776. Kita nak value yang lebih daripada 0 untuk kita nak more meaningful interpretation, so kita tukar kepada 2.776. So dia akan bertukarlah kat sini, seolah-olah more than 50 years will be 1. So kita interpret on more than 50 years. So a person who age 50 years and above is 2.776 more likely to get tumor occurrence than who age below 50 years. This is the way how you interpret the qualitative independent variable, the ratio for the qualitative independent variable in logistic function. Okay, the next one is Gleason score. Gleason score is also the quantitative variable. Okay, the continuous scale. So we find the ratio first, E power of the coefficient of the Gleason score. So we will get 2.9417. So we can interpret it as for 1 unit increase in the Gleason score will increase the odd of getting tumor by a factor of 2.9417 times. Okay, that is the way how you interpret the odd ratio if it involve the continuous scale dan juga a nominal scale for independent variables. Okay, the next one, we also can find the probability of the tumor occurrence. Kenapa kita nak boleh cari probability of a tumor occurrence? Sebab 1 for Y kita adalah yes. Okay, so let's say kita nak estimate the probability of the tumor occurrence if a person is 69 years old with a specific antigen value SAV is 10 milligram per milliliter and a Gleason score is 5. So using the binary logistic regression function that we have earlier, just replacekan di sini the SAV value with 10 sebab dia bagi 10, Di sini 0. Kenapa 0? Because of year of the percent is 69, which is more than more than 50. Sorry, betul lah, more than 50 years old is 0. Okay, 0 kat sini. Okay, and then 5 adalah nilai Gleason Score. So you akan dapat negative 0.729. Ini adalah ln of the ratio. So untuk dapatkan probability, okay, as you know, we can manipulate this ln P over 1 minus P. So last kali kita akan dapat 0.3263. So if a person is 69 years old with the SAV is 10 and the Gleason score is 5, the probability of that person will have ataupun will get a tumor occurrence is only 0.3263. Okay. Okay, the next example adalah from December 2018, question number 5. Okay. A food processing company was interested to determine the presence, the presence of the growth of the CRA 7152 in apple juice based on pH, Nisin concentration, temperature, and Brix concentration. Okay, ini terms, medical terms. Okay, so from the statement tadi, the earlier statement, we can know that our Y adalah the presence of growth or not. The presence of growth of CRA 7152 or not. Maksudnya Y kita adalah Y equal to 1 if it presence, Y equal to 0 if it not presence. Itu adalah Y. Sebab kata presence based on pH. So presence tadi will be Y based on all the variable yang disebut ni adalah independent variable based on pH, Nisin concentration, temperature dan juga Brix concentration. All of this adalah independent variable in continuous scale, kan? In continuous scale sebab semuanya dalam ratio scale. Okay. So untuk logistic it can be Y kita adalah 0 and 1, and then all the X can be all continuous or can be all nominal scale or can be mix of the continuous dan juga nominal. Okay. So dia kata kat sini, discriminant analysis and logistic regression were carried out. Okay, kedua-dua kita boleh guna discriminant dan juga logistic. We can use for this data. Okay, sebab kita ada Y adalah binary and all the X adalah continuous scale. So kita boleh buat analisis discriminant dan juga logistic regression. Okay, so dia kata the output is given in appendix. This is the output. Okay, this is the output of this discriminant. Okay, so from here kita boleh tengok ada no and yes. Dia punya prior is 0.5, 0.5. Okay, and then we have the classification function coefficient. So from here we can estimate the function of D, kan, untuk Fisher linear discriminant function. We have function untuk no dan function untuk yes. Okay, kita ada value D score. And then we have the classification results here. Okay, from here we can see, we can calculate the misclassification, kan, rate, kan, misclassification rate. Kita boleh tengok yang mana misclassify 4 and 10, kan, plus 4 plus 10 divide dengan total of observation, ataupun we can look at this 81.1% adalah correctly classified. So selebihnya adalah incorrectly classified ataupun misclassified. So from that kita boleh cari rate of the misclassification 100 minus 81.1%. Okay, this is the output for logistic regression. So from here we can see that we have the coding for dependent variable is no and yes. And then we have the variable in the equation. From here we can write down the function, the logistic regression function. We have the coefficient b. Okay, and then the walk test, the test statistic of walk, ataupun untuk kita tengok which independent variable is significant, ataupun kita boleh tengok using the value of p value here. Okay, yang mana which one is less than 0.05 or less than the value of alpha, it will it is the significant factor for the data. And then the last column here adalah odds ratio for each of the independent variable. Okay. And then the last one adalah classification table. Okay, so from here we can know the overall percentage. Kat sini adalah overall percentage of correctly classified. Kalau nak tahu yang misclassified, sama juga macam sebelum ni, 6 plus 6 divide dengan total of observation, number of observation, ataupun it just 100 minus 83.8%. We will have the misclassification rate. Okay, that is the output. Okay, soalan pertama, write down the function for linear discriminant and logistic regression. Okay, we can have this linear discriminant function from the output of discriminant here. Okay, we have no and yes. Okay, so if you can see, kat sini adalah D1, di sini will be D1 untuk D yes. Kan D yes here 37, D not, D0 adalah untuk no. Okay, and then the logistic regression we can have from this one. Okay, all the coefficient of beta kat sini you akan dapat the coefficient here. Okay, the regression function here. Okay, soalan B, state the rules of classification for both linear discriminant and logistic regression function. Okay, actually for this one I have mentioned in the previous lecture. Untuk feature linear discriminant, the classification rule, the assignment of the presence of growth apple juice is based on the largest discriminant score. Okay, kita boleh tengok which discriminant which feature linear discriminant that have the largest score. Kan kita tengok yang mana yang lagi largest, lagi more large, so we can classify the newcomers to that groups. Okay, tengok yang the highest value score. Okay, untuk logistic regression we have two. The classification rule is the assignment of the presence of growth, which is y tadilah, sama ada it is for the group 1 or group 0. Okay, if the function is greater than 0, okay, when we replace all the value, so kita akan dapat bila kita gunakan function logistic regression function, kita akan, if the value is greater than 0, so we say that the newcomers ataupun a person to go to the presence group 1. Okay, or if the estimated ratio is greater than 1, ataupun kita gunakan estimated ratio. Okay, e power of the value from the function of logistic. If the ratio is greater than 1, so kita akan classify the new observation to group 1, okay, which is the presence. Okay, the next one, Use both functions to decide whether the growth of CRA in apple juice presents or not if, with pH of 3.5, Niacin concentration of 15, and temperature of 23, and the bridge concentration of 31. So, we will replace all the value of the X dalam kita punya function tadi. Facial linear discriminant function dan juga logistic regression function. We can use both of the we can try for both of the function. Untuk facial linear discriminant, when we replace all the value, D1 juga dapat 27.98, for D0 akan dapat 35.883. So as I said just now, we will choose to classify the newcomers to that group that have the highest score, which is D0, D0 kat sini kan. So we can say that the growth of the CRA in apple juice is not presence. Sebab kita masukkan ke dalam second group. Not presence says the second function has the largest score. Okay, kalau gunakan untuk logistic regression pula, when we replace all the value dalam logistic regression function, you akan dapat negative 8, which is less than 0. Okay, bila kita guna function kan, tadi less than 0 here. Kan, less than 0. Kalau kita guna function. So, function dia dapat negative 8, less than 0. So, we will classify the new observation tadi ke dalam group not presence. Okay, ataupun satu lagi cara sebenarnya untuk logistic, one more method adalah kita gunakan odd ratio kan, which is E power of the negative 8.777. You akan dapat that value. Kalau the E power of negative 8.0777 tadi tu, you akan dapat more than one. Kita akan classify kepada first group presence. Kalau dapat less than one, you akan pergi classify ke dalam second group, which is group not presence. Let's say E, cuba try E power of negative 8.777. So you akan dapat 0 point something, which is less than 1. So we will classify it to the second group, which is group not presence. Okay, the last one, which function, okay, discriminant or logistic, is better in discriminating the presence of growth, in discriminating the Y adalah presence or not presence. Justify your answer. So how to know whether which function is better is, ataupun kita boleh check for the performance of the function, okay, which is using the classification table. Okay. Okay. So dia kata kat sini, kata logistic is better. Why? Because the misclassification rate for logistic is 16.2. Let's see, is it true? 16.2. Okay. Ni untuk logistic. Logistic dia punya ni overall percentage of correctly classified adalah 83.8. So 100 minus 83.8, you akan dapat 16.2%. How about discriminant? Kita tengok kat sini. Sama ada you terus cari misclassification rate 4 plus 10 divide dengan 48 plus 26, ataupun just ambil yang ni saja. Ini 81.1% ni adalah correctly classified. So untuk incorrectly classified ataupun misclassified adalah 100 minus 81.1%, you akan dapat 18.9%. So we choose the function that have the lower value of misclassification rate, which is logistic regression. So we say that logistic regression is better. Okay, so I hope with this example and the explanation, so you can understand better about logistic regression.